Welcome to the next video on Unit 7, doing problem number 5. Remember, first thing you want to do is factor, and the denominator factors easily to x plus 3 and x minus 1. The numerator, on the other hand, the first thing you would do is try to factor by grouping. And when you factor by grouping, I'll just do it really quick. Notice when you factor by grouping, what's inside the parentheses here is not the same, right? And that's what you need to factor by grouping. So factoring by grouping does not work for this one. So we have another way of factoring, which we could do the rational root theorem, which means taking all the factors of 30 and seeing what they go. But taking that a step further, we might want to see if any of these two are factors of x to the third plus 6x squared minus x minus 30, because that would allow us to cancel. So for example, what if x plus 3? So if I divide, and you can either do long division or I'm going to do synthetic division, putting negative 3 in the box. Bring down the 1. Multiply, add down, multiply, add down, multiply, and notice x plus 3 is a factor. It's x plus 3 times x squared plus 3x minus 10. All right, and that factors even more to x plus 3 times x plus 5 and x minus 2. However, those won't cancel, so I'll leave it like that right now, and I'll just cancel these. But first, let's do the domain. So the domain is, it can't equal negative 3 or 1, so it's from negative infinity to negative 3, union negative 3 to 1, union 1 to infinity. And now by canceling, we get the vertical asymptote is at x equals 1. And then the removable discontinuity is at negative 3, right? And to figure out where at negative 3, we can put negative 3 in. And it's negative 3 minus 1. So notice it's 9 plus 9 is 18. Or sorry, 9 plus negative 9 cancels out. So it's negative 10 over negative 4. So it's positive 5 halves. That's our removable discontinuity. Our simplified version of this function is x squared plus 3x minus 10 over x minus 1, remembering that x cannot equal negative 3. So that's our simplified version. That's what we're going to use for everything else now. As far as the limits as x approaches the vertical asymptote of 1, we're going to do from the left. So like if I choose like 0.9, so remember it's x plus 5 and x minus 2. So I'm going to put 0.9 plus 5, 0.9 minus 2, and it's 0.9 minus 1. So it's positive and negative, which is negative, over negative, which means it's going to go towards infinity. And the limit as x approaches 1 from the right of the function, so like 1.1 plus 5 is 2. So it's positive and negative, which is negative, and then positive, so that's negative infinity. So now the limit as x approaches infinity and negative infinity. Well, Notice the highest power is x squared, so it'd be 1 over 0 again. And then we have to determine if it goes towards infinity or negative infinity. So if I put like 100 in, positive, positive over positive, so it's going to go towards infinity. And if I put negative 100 in, negative over negative is positive, over negative goes towards negative infinity. So this one is not going to have a horizontal asymptote because it goes towards infinity. It's going to have an oblique asymptote, and we're going to find the oblique asymptote. Now, in this case, since our denominator is a first degree, we could do synthetic division, put 1 in the box, and go x squared plus 3x minus 10. So you bring down the 1. One times 1 is 1. Add down, multiply, add down. So notice, remember the remainder cancels out for oblique asymptotes, and we get the oblique asymptote is at y equals x plus 4. That's the line. So now to see if the function intersects that line, we set x squared plus 3x minus 10 over x minus 1 equal to x plus 4. And notice when you cross multiply, you get x squared plus 3x minus 4 equals x squared plus 3x minus 10. Those cancel. Negative 4 does not equal negative 10, therefore there's no solution, which means f of x does not intersect the oblique asymptote. So now we're talking about the x and y intercepts. Remember the x-intercepts, you set the numerator equal to 0, so x squared minus 3x, or plus 3x minus 10. Remember that factors to x plus 5 and x minus 2. So it gives you x equals negative 5 and x equals positive 2. Right, for the y-intercept, when you put 0 in, 0 squared plus 3 times 0 minus 10, and 0 minus 1, so it gives you negative 10. So the x-intercepts are negative 5, 0, and 2, 0. The y-intercept is 0, negative 10. So last thing we have to do is symmetry. Then we can graph. Substitute in negative x. So negative x squared plus 3 times negative x minus 10 over negative x minus 1. So that gives you x squared minus 3x minus 10 over negative x minus 1. That means it's not even, because that's not the same as what you started with. And then factor out a negative, so it's x to the squared minus 3x minus 10, then over x plus 1. And that's not the same as what you started with the negative out, so that's not odd. So therefore, f of x has no symmetry. All right, so graphing, we're going to come up here and graph. Vertical asymptotes at 1, x equals 1. The oblique asymptote is a line, y equals x plus 4. So you start at 4 and you do a slope of 1, which means you also can do a slope of 1 the other way, which means it's going to cross at negative 4, 0, 2, 3, 4. So let's do it this way. All right. So that's y equals x plus 4. We also know the x-intercepts of negative 5, 0, and 2, 0, and the y-intercept of positive 10, 10, yep, positive 10, so 4, 5, 6, 7, 8, 9, 10. And then we have the removable discontinuity of negative 3 and 5 halves, which is 2 and 1 half. All right, so now we have points on both sides of the vertical asymptote, which means we don't have to put anything else in, which is pretty good. And we know that to the left of 1, it's going to go up. That's what we found. And it's going to go down as it goes towards negative infinity, like that. And then towards 1 from the right, it's going down. And as it goes to infinity, it's going up towards the oblique asymptote. All right, so now when we talk about the range, well, if you notice, there is a hole, but if you go diagonal from the hole, this other line fills it in. So the range is from negative infinity to infinity, all real numbers. It is continuous on the interval of negative infinity to negative 3, union negative 3 to 1, union 1 to infinity. All right. Hope you enjoyed the video for problem number 5. Have a good evening.